Hello, good afternoon, everyone. Megan, Alexander, how is the day going for you guys so far? It was a little bit of a rainy walk for me back home, but hi Maya, hello Fiona. Glad to have you here. Yeah, I guess we have other courses to do too, right? So yeah, busy working on something else. Yeah. I feel like you finally kind of start to see what teachers' expectations are for you in that kind of second to third week. So, but good for you guys to trying to keep up on your studies. I know that can sometimes be a little bit tough to do as business students, but so I had just a question about the class recordings. So I will, let's see, go over here. So all of our class recordings will be on Moodle, for those of you that are wondering. And right now we're under the topics. Excuse me. So you'll just have to go to the date of the class that we had, and it will say in capital letters class, and that will be the recording from that date. Okay, so I've posted up the currency exchange and taxes questions we worked on Monday, and then whatever we work on today, I'll try to upload that by tomorrow at the latest. So usually I try to get that up on Tuesdays and Thursdays because it does take a little bit of time for me to process those videos and get them up onto YouTube. So these are not public videos, by the way. So if you happen to be showing your face in something, these are videos just between us. So only students that have a link to get to that video would be able to see this video. So it's not a public video, don't worry about that. Okay, let's chat algebra. Today is a big algebra day. So I need to know from you guys how comfortable you are with the following big topics. The two big topics would have been reviewing like expressions and linear equations. So how to expand, how to find a common factor, how to solve a linear equation. So an equation that maybe has only x in it or only has y in it. And then the other big topic for today was working on a linear system. So actually having two different equations and trying to find a solution for both x and y. So in general, yeah, I'm hoping that maybe the factoring, the expansion, solving a linear system is just a nice little review for you. Was there anything that you watched or that you had some questions on here? Or what I would suggest is we might just do some problems with substitution and elimination. And that way you get a little bit of practice in all of the kinds of techniques. That's good. I'm glad you guys, my face-to-face class was about the same. They were like, okay, I kind of get how to do the expressions and the simple linear equations. Where they started to get a little bit more stuck was on substitution and elimination. So maybe it's worthwhile for us to do a couple examples here because these do take a few minutes to do. So let's set up to do a couple examples here. And maybe what I'll do is I'll have you guys, have you worked in breakout groups before, or is this kind of your first Zoom meeting? Have any of your other classes done breakout groups? Okay, so if you do happen to have the textbook, I'm just going to take some examples right out of the text as some practice for us. So this is going to be, let's see, in linear equations, graphing, and solving systems of equations. So we're in chapter 1.5, and I'm going to go over to like page 22. And let's see what can we find, what kind of trouble can we get to in here? Okay, so I'm on page 25. And let's do number 4. Oh, that's dumb. Okay. They're being a little weird here, putting the y's first. So I'm just going to swap. I'm going to say this is 4x plus 3y. I try not to like confuse my students more than we have to be confused. So I'm just going to alter the x's and the y's so that it's, I like having the x's first. I like having the y's second. That's just a personal preference. And I'm not out here to try to confuse you by altering the placement of the x's and the y's. So let's roll with this question. This is very similar to number 4 on page 25. And let's see if we can work our way through this question. Did you guys want me to maybe assign some breakout groups so you have some people to chat with, or do you want to work on this on your own? How are you feeling? Are you feeling social today or not social? Okay, feeling not social today. Okay, that's fine. We don't have to be social today, but we can work on one together. I think someone suggested maybe let's just demo one together, just to kind of make sure we're on the same page. So when it comes to working with equations like this, I typically kind of scan through all of my variables first. So I'm looking at all 4 of these pieces and I'm going, okay, like, is there anything kind of annoying or anything that looks like it might be potentially helpful? Are they the same equations? Yeah, I guess they are, aren't they? That's a real pain in the butt. Okay, well, let's alter it a little bit so they're not the same equations. There. Okay, so make that update to your notes. Let's update this. I would prefer not to put you into a situation where you have to worry about no solutions or lots of solutions. So Laurel, thank you for noticing that. So what I'm going to do is I'm just going to alter the coefficient in front of the y in that first equation, just so that we don't end up getting the same equation. And then typically what I'll do once I kind of like start into a question like this is I'll kind of ask myself, is there anything that like looks like it's a variable by itself, like a variable that has no coefficient lined up with it? Or is there a coefficient, and sometimes in the textbook, the coefficients can be a little messy. So in this case, we do have a messy coefficient of 4/3 x. So those are kind of like 2 things just to kind of keep on our radar. We're going to have to potentially deal with both of those problems. Now, what would you guys rather see? Would you guys rather see a substitution kind of problem or an elimination kind of problem? That's going to, I think, dictate how I move forward in this question. Can I do a poll? Am I allowed? Can I poll the class? Polls. Create. Actually, okay, so. Okay, polls up. Which one do you want to see? Ooh, it's a tight race, my friends. It's like watching the election. Okay, so I feel like most students, about 2/3, are going to say, well, let's do substitution first. We can talk a little bit more about elimination. We can even do the same question 2 different ways if you guys want to see it. So let's start with substitution. Let us then move over into the elimination method, okay? So if we want to use the substitution method, I am going to focus my attention on that y that I have highlighted. I'm going to try to isolate that variable, try to solve for it by itself, and then try to make a substitution. Okay, so what I'm going to do here is I'm going to copy equation number 1 down. I am going to subtract 4x from both sides so that I can get y by itself. Now that I have y by itself, I can substitute that expression I get, -1 minus 4x, I can substitute that into equation 2. Okay, here's equation number 2. And everywhere I see y, I'm going to input -1 minus 4x. So -1/4, Alexander's thinking maybe a -1/4 is a final answer. Yeah, it's going to be kind of a pain in the butt with our fractions, but I think we can do this. So what do we got? 4/3 x minus 1 minus 4x's. Okay, so just simplifying the brackets here for us. And then we want to collect like terms. So let's try to collect together these x's. So we need to figure out what is 4/3 take away 4. So I get, on my calculator, I get about -2.67, or if we want that as a fraction, what is it? -2 and 2/3, -2 and 2/3, so 6, -8/3. Now, the nice thing is, with regards to this course, I typically try to tell students when we're working on equations like this, I think it's fine if you're not as comfortable with fractions as you would like to be, just do the division, right? So just do this as a decimal number, round it to 2 decimal places, because most of the time we're going to be working with dollars and cents anyway. So I think that's a reasonable thing to do. Whether or not you give me -8/3 or -2.67, I think both would be acceptable coefficients for x here, okay? So yeah, I mean, if you wanted to move x's over to the right-hand side, you could. I typically try to keep them on the left-hand side. That's just a personal preference, but it doesn't matter to me what side you move these items to. You just want to essentially get all of the x's on one side and get all of the number things on the opposite side. So I'm going to keep on trucking along, and this should get us kind of closer to what our final answer should be here. So maybe 2.67x. 1 take away 1/3 would be 2/3. Okay, and then let's divide both sides by negative 2.67. And we'll just, if that comes out to be not a pleasant decimal number, let's just round it to 2 decimal places. Okay, so I get, apologies, I get negative 0.25. So about negative 1/4 if you wanted to be, if you wanted to keep your answers as fractions. So that was a bit of a pain in the ass because we had fractions to deal with, but that's kind of the general idea, right? You want to isolate one of your variables, make a substitution into one of the opposite equation, and then solve for that variable. We essentially get a linear equation in x, so we should be able to solve for x. Once I have that, I can now substitute this into really any equation that I've worked with so far. Yeah, so I mean, Alexander's right. If you want to take this solution of negative 0.25, you know, I'm going to sub it into equation number 1 to help me figure out what the value of y is. And then you can always use this other equation to double check your work if you would like to. I'm not going to do that. Okay, I can't bring this. So 4x plus y equals negative 1, 4x. Okay, so here's equation number 1. I know that x is equal to negative 0.25. That should be negative 1. Right, 4/4 gives me a loony. And I'm going to add 1 to both sides. So y is equal to 0? Crazy. Yeah, I guess so. Fiona, no, you don't have to. So, and I was telling this to my students today too, it's like, I tend to write down a little bit more than what I would expect to see from you as a student. So, you know, I don't expect you to tell me that you're using the substitution method. I don't expect you to tell me that you're going to substitute into equation 2, right? I don't expect you to write this. I'm writing this for you so that when you look at this maybe next week, you can follow my steps if you're unsure. Yeah, so you don't need to write down, you should write down something, right? You should probably do a little bit of work so I can see and understand your thinking, but you don't need to write down everything. So that was the substitution method. So what I'm going to do is I'm going to put up So Jason, that's a good question. So Jason's asking, in the textbook, it says, solve this using substitution. My philosophy is that you as students should be comfortable with one or the other, right? You should be either really comfortable with the substitution method, or you should be really comfortable with the elimination method, whatever's easiest for you. I'm generally not going to be of that philosophy where I ask you to use a specific method. I think maybe there's one instance when I might do that, but that's later. I'm probably not going to be specific about what method to use for solving a system because personally, I don't really care. As long as you know how to solve the system and get to a solution, that's really what we want to be talking about anyway, is the solution. Hopefully that's enough to answer your question there, Jason. Okay, perfect. Now, since we just saw a substitution kind of question, copy this one down and see if you can work your way through the substitution method to solve this equation. Of course, if you want to use elimination, I probably wouldn't say no, but I think there's an easy out for substitution here for those of you that want to use it. I think you're a little bit off there, Alexander, from what I think the solution should be. I think x should be equal to 1, if I remember correctly. Yeah, I think Laurel has this. I think it should be x equals 1, y equals 1. So you might have done a small calculation error somewhere along the way. Okay, so Laurel, I'm looking at the textbook now at page 37, question 6. No, I see why you're asking me this question, Laurel, because it gives you 2 exchange rates. Yeah, we'll talk about that at the end of class. Okay. Now I can see why you're asking this question. That makes sense. All right, so if I'm not writing out all of my steps, I might just do something like this. I might say, okay, well, I know y is equal to 6 minus 5x using equation number 2. I am going to sub that into equation number 1. I'm going to expand that through the brackets, this 3 through the brackets. All right, that gives me 17x. And if I add 18 to both sides, I think that's going to give me 17 over here as well. So this is really all the work I would need to see, Fiona, to really be able to follow your logic, right? I can see you're making, you're solving for y, you're making the substitution, and you're just going through this procedure of trying to figure out what x is. Once we know what x is, we can really substitute this into any equation we want. Yes, Jason, I agree with you. It should be 1 and 1. So maybe like 5 times 1 plus y equals 6. Yeah, so for those of you that are saying 1 and 1, absolutely. I think that's a nice example, I think, of what you could realistically see on a test, right? I typically am of that philosophy of if you're in a timed kind of situation, if you're getting an awful fraction like 19 over 13, you've probably gone horribly, horribly wrong. Yeah. Now, that's not to say that if you're doing stuff in the textbook, I know that Joe has made some pretty hard questions in the textbook, so he might give you 19 over 13 in the textbook, but I probably won't give you 19 over 13 on the test. Okay, so that's a little ditty on the substitution method. I know that some of you did want to have a little peek at the elimination method as well. So what I'm going to do is I'm just going to come down, I'm going to resolve this original, okay, why are you doing this? Resolve this original equation. Go, 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 go. Come on, you can do it. There we go. Okay, good enough. Darn Microsoft. Okay, I'm gonna have to restart. So just give me a second here, guys. It's being a real pain in the butt. I don't know why that happens with Microsoft products. Every once in a while when I try to like copy and paste something, it just won't work. Megan, so I use the Surface Pro, and then the Surface Pro just comes with a stylus. I don't know if that, I think Wacom is an actual like pad that you draw on, I think. I can't remember. This is just Microsoft being flaky on my computer, I think. It just, for some reason, there's a little bug, yeah. That if I try to copy and paste something, every once in a while, it just done fucks itself over. Okay, so let's go back to that original question. Let's solve this using the elimination method instead of the substitution method. When it comes to the elimination method, what I typically try to do is, I mean, we could actually go for it right away if we wanted to. I'm going to show you kind of a sneaky trick that we can use to get rid of fractions though too, because I think that's a beneficial thing to be able to do. So if I look at this question, and I look at that 4/3 x, I'm just like, ugh, that's kind of gross. I really don't want to work with fractions. So what we could do is we could multiply that entire row that has fractions by 3. And multiplying that entire equation by 3 will get rid of those denominators. So that's a sneaky trick you can use. If you're working in the textbook and you notice that you have some really ugly looking fractions, just multiply an equation by a number so that you can get rid of those denominators. So what I'm going to do is I'm going to leave this first equation as it is, and I'm going to multiply this second equation by 3. So the point of multiplying by 3 is so now I can kind of cancel out some of these unruly denominators that I don't want to work with. And now I have something that looks like this instead. I like the look of that a little bit more. And we can probably get ourselves into a situation where you don't really have to deal with decimal numbers till like the very end. Or I don't have to work with fractions until the very end. So we got kind of lucky here when I got rid of the denominators. What ended up happening is that this first column ended up looking exactly the same. So I have 4x and 4x. That's really how the elimination method starts. Excuse me, it starts by trying to match up the coefficients of one of your variables. And really the only way you can do that is to look at the starting system that you have and multiply by some number, one of the equations by some number, so that you end up getting a match like this. Now, I mean, for all intents and purposes, you may have noticed that you already had a match right here in the y's. So we actually could have started to use the substitution method right away by subtracting these two equations. But I kind of really wanted to show you this technique of, you have this nice ability to remove fractions if you want by multiplying by, in this case, you just multiplied by the denominator, we multiplied by 3. Okay, so the elimination method actually goes column by column now. Yeah, so now we can go column by column and we can use Fiona's suggestion, and that is to do some subtractions. So I'm going to go column by column in red, and I'm going to perform these subtractions. 4x minus 4x, that's 0. Y minus 3y, that's negative 2y. And then -1 minus -1, that's also 0. Now, the three answers that we get from performing this subtraction lead us to a new equation. Okay, so the 0, the -2y, and this other 0 create a brand new equation that we're able to use. 0x minus 2y, well, technically 0, I guess. 0 minus 2y is equal to 0. So I combine these three things to create a new equation. And hopefully I have the ability to now solve for one of the variables. Okay, dividing both sides by -2 gives us y is equal to 0. I think that's what we had up top, right? Yeah, so y was equal to 0. Perfect. Okay, and now that I know that y is equal to 0, now I can go and make a substitution back into one of the original equations. So let's scroll up, let's grab maybe the first equation, 4x plus y equals -1, 4x plus y equals -1. And we'll just sub y equals 0 in there, so we get 4x equals -1, and x is equal to -1 over 4, or our -0.25 that we saw earlier, okay? So I'll zoom out just so you can kind of see everything bit by bit. So the elimination method basically says, look at a column, try to multiply one of the equations by some number so that you can kind of match up that first column. In our case, I was trying to match the 4x to the 4x. Once I have that, then I go column by column doing subtraction to create a brand new equation that allows us to solve for one of the variables. In this case, it was y equals 0. And then the last step is the same as the substitution method, just sub your 0 back in. And in this case, we got x is equal to -0.25. Someone just said earlier, I was not able to understand this method that seems easier. Don't be fooled, I make it look very easy. It still takes a little bit of practice. I've been doing this for like 20 years of my life, guys. So, I mean, I'm happy that it feels easier, but just because it feels easy doesn't mean you shouldn't do a little bit of practice to make sure you really understand. All right, let's finish off by taking this particular system. So we've solved this one already using substitution. Let's try to solve this one using elimination as well. And that way we have a couple examples inside of our notes, okay? And just as a little word of advice, I'm going to suggest looking at the second column. So you don't necessarily have to work with the x's, but you can if you want to. 2 and 5 are just hard. Yeah, so I think what Fiona said is a nice thing to think about here. I could just take the second equation, I could multiply the second equation by 3 or -3. And then that way you kind of have matched up the numbers in front of the y. I think that's a little bit easier. If you wanted to work with the x's, you'd have to multiply the first equation by 5 to get 10x, and multiply the second equation by 2 to get 10x as well. 10 is the smallest number that I can make. It's going to be similar for our x column. So just to have a little bit of variation, I think it's okay to show you this suggestion, which is Fiona's suggestion. Let's multiply this bottom equation by 3. And I'm doing that so that I can kind of match up my y coefficients, okay? Okay, that gives us something like this. And now, remember what I want to do now is typically I want to use, I think I've told you to do a subtraction. But in this case, it's going to actually be beneficial for us to do an addition. So just to kind of show you a little bit of variation, you have a little bit of flexibility. And the reason I'm doing an addition is because I know negative 3y plus positive 3y is going to give me that 0 that I want, okay? So we're actually going to be using addition. Yeah, exactly, Jason. So we use addition here to get rid of or cancel out the y's to get 0. Now, if that's a little confusing for you, then you could use, I know someone had suggested, Jaskaranjit, I think, had suggested multiplying by -3, and that would be okay. We could multiply equation 2 by -3, and then we could do subtraction. That would be okay as well. Okay, so let's add our first column up, 2x plus 15x, that's equal to 17x's. And then we'll add our third column, which is -1 plus 18. That should give us 17. Okay, and remember these little bits that we get here give us a brand new equation that we can work with. So 17x plus 0 equals 17. Yeah, and so we should be able to see, like Jason said, that we do end up getting that same solution that we had found before, which is x is equal to 1. So, I mean, potato, right? You can, like I said, if you're not super comfortable with elimination, then just make sure you're really comfortable with substitution. Yeah, and like I said, it just kind of depends on your background too, right? I know some teachers definitely prefer really testing the elimination method. Some teachers really prefer the substitution method. So, you know, it's a little bit based on your background too, or where you were taught, where you grew up, and those kinds of things. But this would be the final step. I know x is equal to 1. I can just substitute x equals 1 into one of the original equations to also get y is equal to 1. So we end the same way as a substitution method kind of question, okay? So I would probably say that the elimination method, a little bit harder to set up. The initial step, I think, is the hard part. But once you get it set up, I think the execution is very fast. Whereas the substitution method sometimes has a little bit easier of a setup, but could potentially take a little bit longer in the middle part of the question. So, like I said, potato. Are those enough extra examples for you that you're kind of comfy with the method, or do you guys want to see one more before we go today? What's your kind of preference? Awesome, I'm glad you guys are feeling good. Yeah, if you guys are feeling comfy, like, and that seems like a reasonable thing, this is as hard as the examples are going to get. So I would argue that next Tuesday, when we start looking at supply and demand together, the sample questions are usually a little bit easier than these. What does through the whole class mean? What does that mean? Did I miss something? There's a smiley face in the chat, and I'm confused. Story of my life, by the way. Yeah, so if you guys are feeling good, you can get out of here. There's nothing new that I'm going to be chatting about. Just on your radar, you might just want to be aware that the first assignment is coming up. So if you guys want, you can, over the weekend, just start looking at section 2.2. So section 2.2 is kind of your next assigned reading. It's going to guide you through how we set up and execute a supply and demand kind of problem. And that's exactly what assignment number 1 is all about. Oh, gotcha, Megan. Yeah. So, I mean, like I said, the couple questions we did today are probably the hardest questions that we'll work with. We'll definitely work on like some harder questions. So yeah, maybe over the weekend, you want to kind of just look at assignment number 1. If you are feeling comfy, you can kind of pick 1 to 5. And then in order to get everything going, for assignment number 1, pick 1 of the 5. You're going to come into the group choice. Let's say you want to do question number 3. You're going to click on number 3 and just save your choice, okay? And that way the choice has been saved and I know which question you are going to be uploading and working on for assignment number. So can you open the videos for next topic earlier? Yeah, I'll probably have a recording for you over the weekend, Fiona. So my goal is to get that, I'm hoping to get that done tomorrow. So there's an introductory video that kind of just explains the basics, but doesn't go through the computations. I'm hoping to do a little bit more with some of the theory and the computations tomorrow, okay? So expect that video to be posted, I'm hoping on Friday or Saturday. All right, any other questions? Laurel, I am just looking at this number 6, and I think there's something funky with the calculation. So if it's 0.75 per 1, and we use the 1 over x button, it's actually 1.33. Doesn't make any sense. So
yeah, that was the problem I was having.
Yeah. Because these should be reciprocals of each other, essentially, right?
Yeah, I didn't know if it was just a misprint in the question. They had tried to write the exchange in price, or if there was something I was totally lost on.
No, it just feels weird because it says use an exchange rate of 0.75 US per 1 Canadian dollar. And then, yeah, and then they have this like other assumption, which is also kind of weird. So I don't know which one they decide to use in the answer key, but.
The only answer they give is that the US price is less. So.
Oh, okay.
I came to that same conclusion no matter what they did.
I was going to say, it probably shouldn't matter either way, right?
Okay. I kept thinking to myself, was this something funky to do with the buy-sell price? I thought, no, that's not what this is at all. It's all about exchange and who knows what.
It looks to me like they just got the numbers wrong. So,
Yeah.
You know, if I use the 1 over x button on one of these, right, like if I put in 0.75, right, which is the first exchange.
And invert, yeah.
And I invert, I should get, you know, I should get what what the other exchange rate should be. So I think they just fucked up and just have a wrong number on us here.
Yeah, okay, that's fine.
But hopefully it doesn't affect your overall answer. I think either way you go with whatever exchange rate, I think you should get the same solution, right?
Yeah, just thought I was losing my mind.
No, that's okay. It kind of looks like I'm losing my mind too, so.
Math does that. It also keeps me awake at night. I can't do this too late into the evening.
Exactly. I mean, like I'm already spent. I've been up since 8 o'clock. So usually by the time our class is done, my brain is ready to shut off.
Yeah, that gets worse when you get older.
Yeah. Oh, good. Something to look forward to.
Yeah. All right. Thanks.
Yeah, you're welcome. Yeah.
Okay. Bye-bye. Bye.
Yeah, no worries. Thank you, Fiona. Yeah, no worries. I mean, I tried to do my best to explain the topics in a way that hopefully makes sense. Is it Palika? You can get the book, the textbook, delivered to you in India you can order that from the bookstore. So the bookstore will ship to you. But if you're not able to get the textbook right away, you can still get all of the information you need on Moodle, okay? So for any date that you would like to know, there are readings that you can do if you have the textbook, if you're able to order it, and they will ship it to you. But if that's something that's not accessible to you, there's always these extra videos that you can watch to get the theory and to get some examples, okay? So that's available for you if you're unable to get the textbook. Jason, nice. I'm glad you got that textbook today. Great. Okay, so Alexander, working on assignment 2, some markup and markdown question. Do we need to calculate the net price? Goodness gracious, you're already on assignment number 2. Look at you go. Okay. So assignment number 2, which question? Some markup markdown questions.
Yeah, I guess the first one. So it's mentioned about the net price per item. So is it we design? So is it we design the price, or we have to work out or calculate that price?
Oh, I see. So it'll be the same as assignment number 1. So you'll come into the group choice.
Like
and then you decide which.
So we decide this one. Oh, okay.
Yeah. So you decide. Oh, I want my net price to be 175, and you go save my choice.
Okay, sure. No worries. Okay. All right. Thank you.
You're welcome. Yeah, Balika, I think that's the best choice is just you can use the videos for now. If you'd like to order the textbook, I know the bookstore will do international shipping, okay? I don't know how much it is, but it is available if you do want to get the textbook. Okay, everybody, have a great weekend, and I will see you next week on Monday, and we will do some supply and demand questions.